Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Delete nodes from linked list present in array Leetcode 3217. In this problem, we are given an array of integer nums and head of a linked list. The task is to return the head of the modified linked list after removing all the nodes that have a value present in the nums array. Then in example 1, nums array is given as 1, 2, 3 and linked list is given as 1, 2, 3, 4, 5. Then we remove all the elements in linked list present in nums array and return linked list with values 4 and 5 as an answer. Now because we need to look up the elements from the nums array repeatedly, each lookup operation takes O of n time, right? So which data structure can help us get fast lookups? And the answer is Hashset or hash map. Using Hashset reduces the lookup time complexity to O of 1. Although this increases space complexity because now we have to store the element in the hash set, it is still worth it for the performance gains. In this problem, hash set is sufficient because we only care about the keys, that is the elements in the nums array, and we don't need any associated values. Now let's discuss how to remove the nodes from a linked list. There are different cases to handle. We might need to delete the first node like here, or we might have to delete some node in the middle like here, or we might also need to delete the last node depending on what the values are in the nums array. Suppose this is a given linked list and let's say we need to remove some middle node with value 3. So we start traversing the linked list using an iterator which we'll call current pointer. We can now delete this node when the iterator is at the previous node by skipping that node. So we will just do current.next is equal to current.next.next. We can do the same operation for the last node as well, as current.next will be null, making it similar to deleting a middle node. So we successfully deleted the middle element, we successfully deleted the last element, but we still need to handle the case when the node at the start, that is the head node, needs to be deleted. Then we don't have any previous pointer, right? So we handle this special case by manually updating the head pointer. So we do head is equal to head.next. So head pointer now points to node 2. So when we are deleting a node from the linked list, we have to handle this special case of deleting the head node. And one useful technique in such scenarios is using a dummy node. A dummy node is an extra node at the beginning of the list, typically with a value 0 or -1 or whatever value you prefer. And it simplifies edge cases such as removing the head of the linked list. Now, if we place dummy node at the start of the linked list, then removing the head is like removing any other element in the middle of the linked list, right? Because now head node is not the first node. And because dummy node is never part of the list, we don't have to even consider deleting it, right? So it will always stay. That is the idea. And now we again, suppose we start iterating, say from our current pointer from the start of the linked list. Then we check is the next element needs to be deleted. And if the answer is yes, then we will just skip the node. And we will do like we did earlier, current dot next is equal to current dot next and done. So no special handling is required at the head, making the code cleaner and more maintainable. So now our algorithm is simple. We will convert the nums array to hash set for O1 lookup times. In example 1, we can create a hash set with value 1, 2, and 3. Then we will create a dummy node and set its next pointer to the head of the list. And we will start iterating on the list, say with current pointer. And then we see if the next node's value exists in the hash set, we will delete it by skipping the link. For example, for the current pointer, 1 exists in the hash set, so we will skip the link. So node 1 is now deleted. But note that we will not move the pointer forward because the element next to the deleted element can also be deleted, right? So our current pointer points to dummy only. Then we check if current.next, that is 2, exists in the hash set, and the answer is yes. So we will delete that as well. So now our current.next points to 3. Again, we check if current.next, that is 3, exists in the hash set, and the answer is yes. So we will delete that as well. Our current.next now points to 4. Again, we check if current.next, that is 4, exists in the hash set, and the answer is no. So this time we will not delete this node, and hence we can move forward with the current node. So if the next value don't gets deleted, then we move the current pointer forward. So now our current pointer is here. Again, we check if current.next, that is 5, exists in the hash set, and the answer is again no. So we move the current pointer again. And finally, we have come to the end of the list, and because dummy node was not part of the original list, we will return dummy.next as our answer. And note that our dummy.next is pointing to 4. So we will return modified list with head pointer pointing to node 4. Now let's jump into the code part. First we will convert nums array to hashset. Now we will attach a dummy node to the start of the list. Then we will start the iteration. Let's call the iterator current pointing to dummy node. And while current is not equal to null and current.next is not equal to null, that is, we have not come to the end of the list. Then we check if numset contains next node's value. Then we will just delete that node by skipping the link. Else we will move the current pointer forward. Finally, once we are done, we will just return dummy.next. Now let's run this code. Let's submit this code. Cool. In terms of time complexity, it will be O of m plus n, where m is the number of elements in the nums array and n is the elements in the linked list. And the reason is, first we will loop over the nums array that takes O of m time, and then we will loop over the linked list and that takes O of n time. So overall the time complexity is O of m plus n. And in terms of space complexity, it will be O of m, because we are using this hash set for storing the value from the nums array. So that's it. I hope this video was useful to you. If it was, please like, share and subscribe. The code link is in the description below. If you have any questions or suggestions, please write them down in the comment box. Thank you for watching. Have a nice time.